Every few seconds, a cyber attack happens somewhere in the world. These attacks range from phishing attempts and ransomware to large-scale data breaches, and they're constantly evolving. Many of these attacks don't even start with hacking into a system. They begin with gathering simple, publicly available information about a company and its employees. Team, today I'm going to walk you through our cyber operations analysis of Tesla, OSINT, and its CEO, Elon Musk. Using open source intelligence and tools like Maltego, I gathered publicly available information to better understand the company's digital footprint and possible security risks. Right now, we're in the passive reconnaissance phase. This means we are only collecting information and not interacting with any systems. The goal is to see what information is out there and how it could be used to prepare for a future penetration test. Next, I'll go over what I found and explain the potential risks. Starting with what I found, I began by looking at the main domain, tesla.com. From there, I was able to see connected assets like subdomains, public documents, and employee email patterns. One important thing I noticed was that employee emails seem to follow a consistent format. This means it would be easy for someone to guess other employee emails just based on that pattern, which increases the risk of targeted phishing attempts. I also found connections to other locations like Tesla Australia, which shows how global the company is. Because everything is connected across different regions, this increases the overall attack surface. More locations, employees, and systems mean more possible points where information could be exposed or misused. Using Maltego, I mapped all of this into a graph. This helps show how everything is connected: domains, emails, locations, and other resources. It also makes it easier to see relationships that might not be obvious at first. Even without accessing anything private, we can still get a clear picture of how the company is structured just from public information. Another thing to note is that large companies like Tesla often rely on many third-party services and platforms. These connections can also become part of the attack surface if they are not properly secured, since attackers may look for weaker points outside the main organization. From a security point of view, there are a few risks. The email pattern makes phishing easier. The number of connected systems makes security more complex, and public documents could reveal useful internal details like usernames or system information. In a simulated scenario, someone could use this information to try a social engineering attack by pretending to be from IT or HR. They could make the message look real by using company naming patterns and creating a sense of urgency. This works because people tend to trust messages that look familiar or come from what appears to be inside the company. This is only an example to explain the risk, not something being done. To help prevent this, companies can use things like employee training, multi-factor authentication, and better email security settings such as SPF, DKIM, and DMARC. They can also limit how much information is publicly available and regularly monitor what information about the company is exposed online. Overall, this shows how much information can be gathered just from public sources. Understanding this helps us prepare for future testing and also shows where the company can improve its security and reduce risk. As part of this analysis, I looked at how the information we gathered could be used in a simulated social engineering scenario. Using data from Maltego, such as employee email patterns and company structure, an attacker could make a message appear like it's coming from an internal department like IT. The message would likely create urgency, such as asking the employee to update their password or verify their account, with the goal of getting login credentials. This type of attack can be effective because it relies on trust. Employees may act quickly if the message looks real and urgent, especially if it uses familiar company details. This is only a simulated example to show the risk, not an actual attack. To prevent this, companies should use employee training, multi-factor authentication, and strong email security. Overall, this shows how publicly available information can be used to identify real security risks. From a Christian perspective, ethical conduct in a penetration test requires honesty, respect for others, and a commitment to doing no harm, reflecting biblical principles like loving your neighbor and acting justly. Legally, testers must have explicit authorization under a written agreement to avoid violating laws such as the Computer Fraud and Abuse Act, even if the intent is to improve security. Both legal authority and moral responsibility are essential to ensure the work is done responsibly, with integrity, and in a way that protects rather than exploits others.